Old fiberglass tank which is leaking round the bottom, starting to rot. It's going on a vintage type sprint bike, and the guy that's running it just asked me if I could make one in aluminium, but that was just slightly more aesthetic shape. I don't make many tanks these days, just an odd one or two for friends. Try not to let money change hands, as long as I get my expenses for the material and the people that have helped me in return. For instance, I've made a petrol tank for a Cobra replica kit car, and the guy there helps me by coming to race meetings with me when I'm drag racing my motorbike, and helps me out. So where possible, I try to avoid panel beating. It is so time consuming, and it's a lot of hard work, but I'll come to that later on. I try where possible to make it out of a flat sheet, easier to do. Fold it where possible or curve it. It's easier than trying to juggle several pieces and balance them together while you tack weld it. I put the best side of the metal, aluminium, and downwards onto an old blanket or something like that, or a piece of thick cardboard, so as not to scratch it, and mark on the inside so that any scratches that come from the ruler or whatever you're doing will be on the inside and not the outside where it's going to be polished. And to mark it out with a pencil or a felt tip marker pen, not a scriber. Scribers leave scratches, which especially when they're on a fold or a curve, can turn into fatigue cracks eventually, so best to use a pencil. I cut the metal using a pair of tin snips. I've already cut this piece, as you can see, ready for curving and folding, which I'll show you later on how I do it. Now, when I used to make petrol tanks for a living back in the 70s, the metal was S1CH4, which is half-hard aluminium. It then changed to S1BH4. Nothing seems to stay the same, and it's now known currently as 1050AH14 aluminium, and I use 16 standard wire gauge, which is 1/16 of an inch, which is approximately 1.6 millimeters thick. You'll see some action shots in a minute of me doing some folding and some welding, which I do on oxyacetylene, but first of all I just wanted to give you the few of the basics. If the tank's going to be polished, and it usually is with aluminium, then I use a pure aluminium filler rod, filler wire, or usually I cut strips off the sheet, because then you ensure you get a good colour match. So doing a bit of fine tuning just to get this curvature right. I've got a larger tube in the vise. I've buffed that side a little bit just to see how it looks. Can always be tapped with a hammer at a later date, here and there. In case you couldn't see inside there exactly what I was doing or how it was bent. Just round a piece of tubing, and that was on there, and the G clamps were on there. piece of wood and some cardboard or newspaper underneath it so it doesn't damage the metal, and the same underneath that. The machine is just an old washing machine motor with a buffing wheel attached to it. Simple as that. It's a little bit underpowered. If you press too hard it can stall, so you just have to take it easy. It's got a slight advantage to that, in that if you've got a buffing wheel that doesn't stall and you press too hard, you can actually buckle the metal that you're polishing with the heat that's produced, or put grooves in it. Okay, now I'm using a piece of tube and the vise. Putting some knee recesses into this. The original didn't have them, but he wanted a bit more shape in the tank. So that's what I'm trying to achieve. Just have to be very careful here so it doesn't kink it too sharp. I just do the curve the other way, over my leg, over my knee. It's a bit more there, that way. I hope that can be seen clearly enough with this tube onto the back. Simply got a round billet there. Happens to be aluminium, that one. I just use that to get the curve. I've adjusted a bit with my fingers so we don't get any kinks in it, hopefully. If there is any, they'll have to be tapped out. Just to go a bit more up there and towards the top. Which is not as easy as it looks. A bit more of that. This is all got. That has to be curved, that's got to be curved yet, and that. Always make sure when you're working on the bench that you've got some nice smooth metal, some paper down there or cardboard, otherwise any marks in the workbench will get transferred to the metal. If it's got to be painted, obviously it doesn't matter too much, but with a polished aluminium tank it does. Also, always make sure that the end of the tubing that you're using is there's no burrs on it, otherwise that will put marks and dents into the job. That's how I curves, such as that one. Making the tank in one piece makes it much easier to set that up for welding rather than to try to balance separate sheets, separate bits together whilst trying to weld them. That's ready for going to be welded. Before it's welded, you need to rub these joints so that they're clean, and the edge as well where you can get at them, and also inside there. That makes it easier and better for the weld to penetrate and run in properly. I don't like emery cloth. Don't want foreign pieces of metal getting into the joint. The hardest part is tacking it up. Always put a bit of warmth into the metal first with the torch, or put it in front of a heater. I'm using strips off the metal at the moment to keep the colour match correct, because it's going to be polished this when it's finished. You can see it warps and twists. I have a heat resistant glove or a pair of grips of something description like that. Let's see if we can get this where I want it. Want a little bit of a gap. That's not stuck properly. Using aluminium welding flux, obviously. It doesn't matter too much what these welds look like, and they're going to be filed off. That's better, I think. Have a little hammer ready. You'll also need one of these when you're filing it. If you get any low spots, you need to knock them up. Any high spots, of course, knock them down. See, that's sinking in a bit there. It's best to start at this end of the joint when you're tacking it. If you try to tack it from the other end, you might end up with a loop, like bolting a cylinder head down. You start where the highest point would be and pull that down first and the edges last, so we tack it that way. But when you start to weld it, don't weld it towards an open end, like there. Weld from that end, give it a few good tacks on that end, a few more, and then weld upwards. If you weld towards an open end, it can split as it expands on the open end where it's not held. Screwdriver stuck in there for a moment or two just to stop it twisting where you don't want it to twist. You need 3 hands really. Sometimes you may need 2 hands to make an adjustment. So if you need to do that, make sure you've got somewhere safe to put the torch down without turning it out, because you don't want to lose heat in the metal. You've got to start all over again then. You can sometimes play the torch if you want an area to lift. Play the torch on that little bit more than the other. Sometimes you need to shield it so play the flame on the rod if you don't want it to twist somewhere. Have some blocks of wood handy so you can position the tank where you want it, and I've got it on a fire blanket so that it doesn't get scratched. I've got that held at the end there. Come back to it last. This is the other side that I'm on now. Don't attempt to weld it if the metal is cold. You need to get some heat into it. And you've got to work quick. Otherwise you'll end up with a hole. And this is an old BIG tip and torch. It's a number 2. But whatever you would use for welding 16s gauge steel, or the next size up for aluminium, you need a bigger tip, because aluminium dissipates the heat a lot more quickly. If the tank's going to be painted, you can use a 5% silicone rod. That runs in a lot easier, just at slightly below the melting temperature of the metal, and it gives a good fillet on the inside after you've filed the outside. But its colour match isn't correct if the tank's going to be polished. If it's going to be painted, then there's no problem. It can be a bit awkward going uphill, vertical welds. Try to position the job so that the majority of it is going to be on the level. Don't attempt to chip the flux off it, just mess the tank up. Just use boiling water. The flux is very corrosive and it leaves marks in the metal, but they'll be rubbed out with the wet and dry paper and the polishing wheel. Bit hot that. Outside and in, so I'll need another kettle full in a minute. To file these welds up using a very rough file, a dreadnought file, more like a rasp, and then a fine file. Notice chalk on that, it helps to stop the file clogging with aluminium, well I find it does. And then progressively smoother wet and dry, starting at about 100 or 120 grade and working down to about 600 or 800, either with a rubbing block or with your fingers. That's the next job. I'm not going to show every process as the video will be too long. That's filed up, not ground. One slip with a grinder and the job would be wrecked. Need some smoother files on it yet, and wet and dry paper. The wells now filed up. Rub down with the wet and dry paper. There's a total of 11 hours taken to do those, spread over several days. I'll turn the tank over and put some warm water in it. That was to check it for leaks. Leave it for a couple of hours. Still got to form the front yet, the form bit round there to replicate the fiberglass tank where the strap goes around it. That's yet to do. Just upend it. If you use cold water you get condensation on the outside of the tank and it's damp, and then you think you've got a leak when you've not. If you get a small pinhead hole in the weld anywhere, it's probably just a bit of flux that's trapped in there. Clean it out, small file and just or a scriber, and just clean it. Preheat the tank and just put a blob of weld over it again and file it up. It occasionally happens. Now I've swaged the neck, drilled a hole and swaged it just through a hole in that piece of timber. Filler cap will be welded round the inside of there. Bit of a juggling act to get at it, and you've got to be careful going past that area because it's a bit flimsy, those prongs that hold the latch, so I usually wedge it with a couple of pieces of aluminium to take the tension off that spring and get round there pretty quick. And there'll be a 5% silicon aluminium rod used to weld that. Just used a similar thing to do the hole for the breather pipe. Hole in a piece of wood and just used a round-headed punch. That's how that will be. So that's the next job. Filler cap and breather pipe now welded on. That took about 20 minutes or so to clean it first. Always clean and weld within an hour because an oxide starts to build up on the surface of aluminium after about an hour. So you need to weld as soon as possible after you've cleaned, and then wash the flux off, and if there's any filing or buffing to do anywhere, like down there, do that as soon as possible because the flux is very corrosive and it can start marking the metal. So the next job now is to make the bottom. Squeeze in a bit more yet. It's 2.5 inches, and it needs to be wider at the bottom to match the sample. And the little cardboard template. think that's fairly near. I've left surplus metal on the sides because there's more folds got to be done yet to match those, and then it's going to be trimmed, cut to suit the tank top shape. Just left a bit of extra metal in case I made a mistake. The bottom is now more or less done. Just needs that bit trimming off there so it fits neatly to that. Now you will notice that I've folded the bottom edges, or curved the bottom edges of the tank. Two reasons. It's easier to set the bottom up so it doesn't drop inside, trying to balance it there. Look at this one's got a flat bit there which makes it easier, but sometimes the bottom isn't like that, it can drop. It's difficult to keep it in position, so that helps to do that. Also, it reduces any chances of the side buckling. If you were welding right on that edge along there, if that wasn't folded over, there's more chance of that wrinkling. So that helps to stop it, moves the heat source a bit further in. And when you're welding, you can alter the angle of the flame. You can point it more shallow that way, get more heat. If you're getting too much heat, you can shield it with the welding rod. If you want a bit more penetration, you can point it further down. Just experiment. And make sure when you're cutting things out, you've got a pair of left-handed tin snips. Now this isn't a joke. If you have a look at those, you can see, I hope, the angle, the hand is opposite. They're not just for left-handed people. They're for some certain cuts you can't get with the right-handed snips, and vice versa. So if you've got handed snips in both directions, left and right, you can get all the cuts. Lost a little bit of heat there, getting the camera set up, just to take this little bit, make some tacks on there every 3/4 of an inch or so. Once it starts to melt, you've got to move quickly. It goes matte and slightly wrinkly and the flux starts to run. That's when it's about to melt. It doesn't go red like steel, obviously. Done that bit along there. That's the narrow edge that couldn't be folded over very easily. I've used the 5% silicone rods on. They flow in rather than forming a lumpy weld, so it'll need a little bit of trimming up. Same around the front end. Do have some heat resistant gloves handy when you're doing the job, so you can move the tank about without burning your hands. Next job is to test it for leaks and then polish it. That's the bottom welded in. Now normally if I'm working with a bike that I've got with me, I normally make the bottom first because it's easier to sit it on the bike and make it fit. Then you can make the tank top to fit around that, but here I've been working from a sample tank and did not have the bike. That's been trimmed up now. I did actually scribe a line on the garage floor, an outline around the original fiberglass tank, to make sure I got the new one as near as I could. Take measurements as well, of course, and patterns. Tank polished and finished. There's approximately 37 hours work in total gone into making it from start to finish, spread over several days, of course. Now, I have heard it said that it's easy to make an aluminium tank compared to a steel one. Well, it might be easier to form the metal, being a softer metal. But if you're going to make a steel tank, it's obviously going to be painted. And that hides a multitude of sins. So if there's a few ripples in it, or hammer marks, or other marks, the painter comes along, puts his filler and stopper on it, rubs it nice and smooth and paints it. You can't do that with an aluminium tank. That finish has got to be perfect. Otherwise every little ripple and hammer mark will show. So, in some respects, making an aluminium tank is harder than making a steel one. There's another view of it from the back, just comparing it to the other one. He wanted a bit more shaping in the new one, which I've done. Now, before I close, just a little bit about panel beating when you need to do a double curvature shape. So let's look at how I do that. I don't have a wheeling machine. Sometimes you just have to do some panel beating where you've got a double curvature shape, a dome shape. I try to avoid it where possible, but there's some tanks that just require it. It depends upon how big the piece is, whether you can use a mallet like I've just filed to shape there, or a ball peen hammer if the job is a bit smaller. Just use a piece of tree trunk. I'm not going to do it all. Doesn't take long really to get the actual shape that you want. Then comes the laborious bit, because what you've got to do then, I've just made this device out of an old axe type head on a piece of tube, put a slight curve on it, make sure it's nice and smooth, and then just gently tap all the hammer marks out. What you've got to do next, flat it with a rubbing block. If you use your thumb or finger, it just follows the irregularities, so you need to get the high spots off with that. Then you're left with little low spots. So what you have to do then is find the little low spot and tap it up and go around every little individual low spot and tap it back up and then flat it again. That's how it ends up after it's been polished. But you can see all the little hammer marks inside there that have been individually tapped back up, all the little low spots, and then flatted until it's nice and smooth. It's not got a massive double curvature on it, but there's some that was cut off. This is a scrap piece from what was left over, that's the edge of it. And that can take hours and hours to do. That is precisely how I made this little tank, which is on one of my sprint drag bikes. You can see the double curvature on that. All panel beaten. but it takes hours to do, and there's several pieces of, several sections welded together there to form the overall shape. These are the chain and clutch guards I've made on my old double engine Triumph two-faced. These are stainless steel, and this is a lot harder to work with. All formed by hand. The slots were drilled out. That is arc welded with an old arc welder. I just touched it on and off so it didn't blow holes in it, and then filed it up, and I used emery cloth on that. Wet and dry paper is not tough enough for stainless. And this is just curved around a piece of tubing. The tank on this bike I'd never made. It's over 40 years old, this bike, and I didn't know how to do this sort of, well, not tanks, aluminium tanks. I did the chain guards, but I didn't know how to make aluminium tanks. All weld aluminium back in '68. So I got a sheet metal worker to make that tank for me. It's been on there for over 40 years and it's still as good as new. A steel one would have been full of rust holes by now, but since then I've learnt to do all my own aluminium work, as you've seen with the tank that I've just shown you how I've made it. Now to the Hayabusa that I'm currently running at the moment. Now if you imagine that being a flat sheet, completely flat, opened up, I put the recesses in there using a wooden former, front and back, to replicate the Hayabusa shapes, but I made the tank a lot flatter. There's a big hump on the Hayabusa tank and you can't get low down on the bike. So that started as a flat sheet, and then that is curved down. It was out there, I imagine. So that's curved down. And then this is welded all the way along there. That's a separate piece. That's a weld. That was just shaped over my thigh, over my knee so to speak. That's a weld down there, all filed off and smoothed, as you've seen me do on this recent tank. Now the front aluminium fairing that I made, because the original wouldn't fit after I made several modifications to the front end, lowering it, altering the forks, moving the handlebars straight instead of on an angle. So that started life as a flat sheet, which we'll have a quick look at now before I describe how I did it. I just cut those pieces there because they had to curve in. Cut that part so that had to curve in. I formed that over an old propane bottle with some cloth on it to take any sharp edges off. Got that shape in, and that shape like the Hayabusa, and that shape. Because that was cut and this was open and that was open, that bottom edge would fold in. So that's welded there and there. The only panel beating on it is that little front nose section there. Other than that, it's one piece. There's a little piece welded in there to form the headlight recess, or the replica headlight recess. And obviously the air inlets are separate pieces. They're just dummy indicators made of fiberglass. Those were a little addition for my top speed run at close to 200 miles an hour. The air can push the levers apparently, so I put them on as an afterthought. The screen I made in my oven out of polycarbonate. What else is an oven for? So that's it. One thing you might be surprised about is that I'm not a sheet metal worker or welder. This is what I've just taught myself over the last 40 years with running my drag bikes and making bits for them, and then gradually getting good enough to make things for other people. I'm an electrician by trade, worked on 3-phase 415 volt electrics, 6,000 volt transformers, overhead cranes, stacker trucks, electric trucks, wire drawing machines, and of course 240 volt domestic electric. So if I can do this, anybody can. It's about 20% knowledge and skill and 80% hard work. So let's have a look at a few of the other fairings and tanks that I've made over the years. A couple of photographs and some old VHS movie clips. From 16s gauge aluminium sheet.
So you've got your two tap holes and all going, yeah. And the,
Oh yeah. Lovely.
I think that's quite nice.
It is. Beautiful.